And then what will do you have the files, the PPT files, or any files that you have for the presentation? If you have a phone, like a smartphone, you can record with your phone, right? Have you checked your other friend's video? Have you checked your other friend's video, Maria? I think you can check the other video for your reference. You can record. Yeah, yeah, you can just upload the PDF file so that your friends can read. Well, it's better. Are you using a laptop or a smartphone for video? I think you can record using those devices. Do you know how to record? Yeah, I think you can. If you use an iPad, you can uh, record your screen and make some presentation on your screen. Don't forget to turn on the microphone. So in the recording side on your iPad, you need to touch it, and then there will be some options: microphone off or on. You need to turn on. Usually the settings default is off, so you need to turn it on. So that's how it does. Okay, you can look at how to record the screen. I think there's so many tutorials on YouTube. Okay, try that, and yeah, I think that's okay. That's okay. Video 25 minutes. That's okay. That's okay. Because we need to watch the videos before we start the presentations. Okay. 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 I will wait your video by today tonight. Okay, if you have the time to record. Okay. 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 So we will have some topics today. The presentations, because I asked some of you that I think you prefer doing it online using your laptop, right? For presentations. I think that will be better. And also we have one student who cannot come this semester, one student. And there's two, but the other one already have temporary leave. She will be back next year. One student, I think we will have her until the end of the semester, but she cannot come to Taiwan. So I think it will be better for us to have an online presentation. So prepare your files, whichever you want. Okay, you can have your PPT because some of you prepare the PPT files, right? Some of you prepare. I think Jordan and Kenzie prepare in a Kenzie is you're writing with OneNote, right? Jordan with just a paper. You can prepare either way. If you want to maybe take some setup using the OneNote, you can also you can share your OneNote, right, in online. And Jordan, you can think any options that you have. You can maybe using similar OneNote, or you can transport to the PPT or any presentation file if you want. If you want. But if you prefer doing it like using the like a pen, I'm not sure how it works, but there is options. You can use your smartphone and connect your smartphone through some apps to your laptop and share screen that uh, the camera on your phone to your laptop. I think there is a method. I've tried once. I think you can do that. There's a lot of apps that can share your camera. I think one of them is called the Epoch Cam, and the other one I forgot the name. I think it's free, but they will minimize the resolutions. If you want to have like high resolution, they will have like the paid version, the pro version. So basically, you present. Yes, that's okay. So you can present the summary of your video. So it will be very short, not really long, because some students I watched the video. Some students make it very long, like 30, 40 minutes. Some students make it very maybe short, like 10 to 15. So the presentations should be very short. Okay, so it should be maximum 5 to 10 minutes. 5 to 10 minutes. I think 5 minutes will be better. So what you need to explain in video is first is summary. Okay. Uh, let me write here. Okay, let me write here in my notes here. So the the presentation. So you don't need to uh, restart your video explanation. So the presentation is more about the summary of your video. And the second one is should be about the applications. If there is some application that you think you can explain, okay, application of your of the topics. And if you want to add like maybe some uh, interesting fact or ideas, okay, but maybe not all topics have this, but if you can think one, you can also add to your video, to your presentation. I mean, this will be around, I think 5 to 10 minutes should be enough. Okay, 10 will be the maximum. And after the presentation, we will have, so this is presentations, we will have the discussion. So the discussion part, okay. Uh, yeah, Maria, that's okay. Solving examples, okay, but you need to explain maybe short uh, in the first in the early minutes that maybe what is your topics, maybe definition or something, and then maybe you can go to some example. Yeah. Okay. Okay. So discussion part, I will have because we will do it online, so this will be online. All will be online. So discussion part will be uh, about if you have any questions to your friend, okay, you can prepare questions. 1, 2, 3 questions. Okay. You can watch the video to maybe asking some question here. Need to watch your friend's video. Okay. You can write in the chat box. Okay. Or if you want to speak, you can also speak if you want. If not, then you can just write on the chat box, and I will notice who is asking and what questions. And it should be questions relevant to the topics. Okay. Okay. Mm-hmm. So you prefer present in the class? Yeah, summary is just like yes, 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 yes. You can. I think you can just write in your PPT if you want. Yeah, yeah. PPT is okay. I think just 2 slides, 3 slides is okay, right? Yeah. You can just if you want to use some. I think you can copy the picture and then just put into your presentation. And if you want to add, maybe adding some uh, examples if you want, like how you can use it, or if you want to um, explain uh, how we can use it. I think you can do on your PPT. Okay. Okay. So also the uh, of this part, the application. Okay, it can be some real world problem if you can think one way, uh, or you can think of some example, any question in math questions. This can be possible too. Depends. Okay. I think this will be enough for 5 to 10 minutes. I think, right? Summary maybe 2 minutes, 3 minutes. Application maybe 1 to 2. Interesting fact for idea, or maybe just 1 minute. Like maybe you have idea in your mind that okay, maybe we can use it for this. Mhm. Yeah, it's okay, it's okay. But if you think like there is some advanced topic that you can show off, um, I know that some part of your topics is including the spherical cylinder parts. Okay, you can talk it like when you can use it, like maybe which part you can use it. Not explaining like very details. Maybe you can just use imagine like maybe engineers can use it for this, or maybe if you have application in maybe computer science, or maybe some mechanics in a device. You can just mention it, not explaining about it. Okay? Just mentioning, not explaining. Okay? Because if you need to explain, you need to understand the whole system, right? How this can run. But if you can't, that's good. If you can, that's good. But I think it's okay if you just mention some of them. Okay. And of course, I will also. So the third part will be uh, additional notes. Okay. This is from my point of view. Okay. I will explain what can we elaborate in the presentation. Okay. Okay. Any questions first? Any questions? Maybe online students, do you have any questions? I think most of you did a good job. Uh, I was surprised that you prepared very well for the topics and the video. Uh, I need to remind you as well that we will have a report. Okay, this is basically what I expect for the report is basically a continuation from your video. Okay, what you can add and what you can actually what you present is actually what you will be reporting. Like your report is include like your summary of the presentations, what can you do for that topic. If there's any additional information, you can also put into your report. I mentioned that the report should be in the video, but if you think the video is a little bit uh, you need efforts and time, right? You can make it into like a PDF file if you want. you can write like in the PDF file or a PPT. I think PDF file should be okay. PDF file. This should be okay. Hans, okay, you cannot come tomorrow. Okay, that's okay. That's okay. Okay, that's okay. That's okay. Okay, so Hans and Jonathan, that's okay if you cannot come tomorrow. You will have your presentation next week. That's okay. Okay, I think report PDF file. I think it's okay, right? Uh, or do you want make another video? I think too much effort for video, right? Just PDF, right? Okay. Okay, just PDF file. Okay. So this report will be contributing to your uh, final exam, probably 40 to 45%. Okay. Uh, the percentage, however, will be also depends on your actual score and your in your exam. If it's bad, I will increase this. Okay. Okay. Any other question? Any other question? Oh, this one. This is my part. My part. So if I want to make some additional, I will take some time in the presentations. So maybe if you present, and I think there is one thing that missing, I will add those things. Okay? So you will have more perspectives. Okay. 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 I think that's it. So presentations tomorrow. I will maybe continue a little while for 2 days. Let me check what will we have. Yes, the report. Uh, I think around January, first week January. I think. Okay. I'll yeah. Hmm? Yes, yes. I will put in the Google Classroom. You can submit through the Google Classroom. So I will have so expected the report after we finish all the presentations. So all students already present, and the report will be soon announced. Okay. So we will have. I think we have now is 5 students and 8. So the total of 8 students. We have tomorrow 1, 2, 3. Okay. So every each day you will have at least 2 presentations. Yeah, 2 presentations, 1 or 2 presentations. Okay. Sometimes maybe I think maybe for Wednesday we will have just one. For Tuesday maybe two, okay, or three, 2 or 3. Okay. I think that's the presentations that you need to prepare. Okay. Okay, let me check the. Oh, I think I will go just through the conic section because no one doing that for a while. So I will just. Oh, I will. Maria. What topics are you? What topic you prepare? Only parabola, right? Or what else? An ellipse. Okay. I will go through the. Uh, Okay, I think I will go for trigonometry part because Jordan, you are in the more analytic trigonometry. I will go for the right triangle approach. Okay, I think I should giving this a last week, but we don't have time. Okay, so let me just go through it. Okay, this is chapter 6. Okay, so let me continue for a while. So topic will be this is chapter 6. This is trigonometry, but more of right triangle. Okay, first let me take uh, the measurement of the angle. Okay. We call this is the initial side. This is also initial side, and we call this terminal side. I think this also relate to a polar coordinate. Okay, this is before we learn the polar coordinate, we learn about the angle first. The angle, and we have an angle there at theta. Let's say this is A, this is B, this is O. Okay, we call this is a positive angle. Okay? I believe you are familiar with this. And if we have this, if the angle is from the terminal to here, so this will be the negative angle. So we start from the angle. Okay. And from the angle, if we try to make a circle, okay, if we try to make a measurement inside the circle like that, we call the part on uh, we call this part here. This is a radian measures of the angle. Okay. The total circumference is 2 pi, 2 pi radians. Okay, so if angle 180 degrees, this is equal pi radians. So 1 radians is basically 180 divided by pi. Or 1 degree is pi divided by 180 radian. Okay, this is just a review on radians and angle measurement. Okay. Okay. The other thing that is important is okay, the circular arc. Okay, the circular arc. Okay, the total angle for the circle is 2 pi. So the circular arc is theta divided by 2 pi multiply with the circumference, or this will be 2 pi, this is 2 pi r, or we can write theta r. Okay. And we can also solve for the theta. So this is s. Theta is s over r. Okay, just to make sure, confirming that this is the arc length. Uh, and the other part is if we have the area of this, okay, area. We call this sector, area of a circular sector, or simply we usually call by sector. Okay. So to imagine, this is, I think, pretty easy to imagine, like a slice of a pizza. Okay. So it's a slice like pizza, okay, and you can calculate this, the circular arc, and you can also calculate the area. Okay. And how to calculate is basically similar to what we have done in here. Basically, we just make proportions with the angle, with the whole circle. Okay. So we can write down the area as theta over 2 pi and area of circle, or this will be, okay. Now this will be important in the polar, okay, in your part. Okay, this will be important. Later, the polar coordinate, this topics here, the theory of the circle, area, sector, you will be using most of it on calculus 2. So usually, okay, if I'm explaining in a simple way for the calculus, usually your curve is, let's say you have like maybe like that, okay, and you want to know the area here, right? So if you have the f of x here, and usually what you do is you try to slicing up the area, right, with a rectangle like that. And you know that this will be the x, this will be the height, or we can say this f of x. And we can impute this and have uh, sum for all of these rectangles, right? For integrals. Okay. Now, similarly, if you have this is done on a function of x in xy graph, right? In polar, you have r theta, right? You have equations, uh, polar equations like r maybe sine theta, or r is a cos theta. And if you draw in not in xy but in r theta graph, the graphs will be different from the xy coordinate. But still, okay, still, if you want to calculate the area, we're still using the same theory. The difference is we are moving this xy to the r theta. Okay, and one of the idea is we can start using this application of the area, r squared and theta. Okay. Oh, we will learn this in the calculus too. So you will be expecting to see of this in the future. Okay, okay, that's the sector. Okay, our area, a circular area of sector. Okay, I'll go to the next slide. Okay, now this S we can have a circular motion. Okay, and I think we have learned a little, or maybe sometimes in physics, okay, we can have an angular speed, or we call this omega. This is with respect of time, this will be the angle. And the linear speed is, we know that this is s over t, right? And our s is the distance on the circular motion, or we can write r theta divided by t. This is more or less about physics, so I don't want to elaborate uh, in more details. And between these two, we can have, of course, that we see that this is an omega. Let's say the intro. Okay. The trigonometric part is in the next section. So here is trigonometry on right triangles. First is, let me draw the triangle. Okay, we call this the opposite. Okay, this adjacent. I think everyone knows, right, what this is. And a hypotenuse. Okay, based on the definitions on the right triangles, and based on the ratio, we can have sine theta is opposite divided by hypotenuse, cosine, this is adjacent, divided by hypotenuse, and tangent, this is opposite divided by adjacent. And the cosecant is just the opposite of the other one. Secant also opposite of cosine. And cotangent is also opposite of the tangent. Okay. Some special triangle. If this is 1, 1 square root of 2, then this will be 45 or yeah, 45 degree. 45 degree. Some special angle. The other one is maybe that. This is 3, 1, 2. Yeah, some special angles with special ratio. I think most of you know how to use most of all the special angle. And I think I expect that you already know how. So I will skip some parts. Some problems is just a review, and we can skip to the next sections. So I think I will finish the whole chapter 6, okay, by today. Okay. The next part is trigonometric functions of angles. So after we get the ratio from the triangles, we can draw in our Cartesian x and y. If we draw this, we can simply write down our uh, our trigonometry in terms of y and r, x and r. and tangent y over x. And the r itself is the circle equation. I think you're already familiar with this, so no need to focus on. And also from here, we can develop the quadrant. I think I already mentioned before, right? So quadrant 1, quadrant 2, quadrant 3, quadrant 4. This is all positive. This is sine that is positive. This is tangent that is positive. This is cosine that is positive. And the reason why is, I think most of you know, right? Because if we look at the x and y, based on how uh, the x and y position, we know that the sine, because it's the y over r, that should be a positive, and the cosine, because x is negative, so that will be negative, right? The same way with the other part. Okay, I think I already mentioned this before, so this is just a review. Okay, let me look. Okay, and then we also have the okay, we have the reference angle. Reference angle is the angle, the smallest angle that you can find uh, within the trigonometric function. So for example, if I say that sine 240 is 240 degree. Sine 240 is, if we take some graph, this is pi, right? Oh, wait. This is pi, or 180 degree, or pi. 240 is from 180, we got a little bit 60 around that, and this will be our positions, right here. Okay. So the reference angle for 240 is 60. Okay, you got it? Okay, so this is just a review from your high school. We call this reference angle. So 60 is the reference angle, and we can write, because this is on the third quadrant, this will equal minus sine 60. The value will be equal. So sine 240 will be equal with the negative sine 60. Okay? Just for your reference. Okay, for your reference. Okay. So remember all the quadrants that I taught previously in the lectures, and also remember the reference angle is the smallest angle that you can find through the quadrants on your trigonometric functions. Okay, so that is that. Okay, now let me move to have some basic identity of trigonometric before we going more details into analytics, okay, later. Okay, let me write first is, remember that sine theta is y over r, cos theta is x over r, tangent theta is y over x. Okay. Okay, if we take sine squared theta, this will equal y squared r squared. Okay. If we take the cosine to be squared, this will take x squared and r squared. Okay. Now, if we look at this too, okay, if we take the sine squared theta plus cosine squared theta, okay, we can also look at how uh, the y or the ratios will be. Okay, so this will be y squared and we know from the circle equation that this is r squared, right? And it's equal 1. So using this uh, ratios, you can prove that the sine squared theta plus cosine squared theta is 1. Okay, so this is a basic identity for trigonometry. And from here, if you multiply with 1 over cos squared theta, we can go back and revert this into tangent. Okay, so this will be also this basic identity. Okay, so this two, the tangent and then this tangent squared plus 1 and sine squared plus cos squared will be our very basic identity. We can use it in most of trigonometric functions cases. Okay. Okay, the next one is more about the applications. Okay, applications. In this case, this is the area of triangle. Okay, let me draw the triangle. Okay. Okay, let's say we have this triangle, and we know that if we have a right triangle like this, we know that the area is half base and height, right? Okay. So when we have random triangle, okay, random triangle, what we can do is we take the line in the middle here to make it the height, so that the angle in between here is the right triangle or 90 degree. Okay. Okay. And still we have the area is half A H, right? Okay. Okay, now the h is or the angle. If we want to write as a sine, then this will be h over b. Okay, and the h itself becomes b sine theta. So we will have the area cos a b sine theta. Okay. What is if okay, if we have the angle is here? Okay, what if we have here? The angle is there. This is A, this is B. Okay, what will happen? We can take the height in this way. So we will have this is another angle that is 180 minus theta. And let's say this is H. That's H. And our H will be based on the sine of, maybe let me write in the sine. So sine 180 minus theta is H over B. Okay, now these terms, remember the sign here, 180 minus theta is the second quadrant, which is sine is positive. So we have B sine theta. So the area of triangle is, again, it's half A B sine theta. Okay. And please remember this triangle. Okay. Sometimes in um, calculus, we need to be expected to know the formulas, okay, or to know how we solve the geometric parts. Okay, now we move to the inverse, okay, the inverse of the trigonometric. Inverse of trigonometrics. Okay, remember that sine theta is y over r. Okay, if we draw, okay, let's say this is the angle. This is r. This is y. This is x. Okay. Okay, if sine theta y over r. Okay, remember that the inverse, okay, let me write in the green color. So in inverse trigonometrics, what's important in inverse of trigonometric is we need to restrict the domains. Restrict the domain. Because, okay, if you remember correctly, if this is the sine curves, okay. If we take the horizontal line and checking whether the function is one-to-one function, this is horizontal path. We have more than one point here, right? And meaning that it is not one-to-one function. So we need to come up with the idea how we can have the sine functions or the trigonometric functions have an inverse. So the first case in sine, we will restrict the domain between here and here. This is negative pi over 2. This is pi over 2. Okay. So that way, we will have the inverse. Okay. So we need to restrict the domain to have an inverse. Okay. So restrict domain to have one-to-one function, and thus having an inverse. Okay. So in our case here, the domain will be just this 1 and 4 quadrants. Okay. So 1 and 4 for the sine. This is negative pi over 2 until pi over 2, the domain, okay, the inverse. If we have cosine, this is x over r. Let me just draw similar line with that. So r, x, and then y. And if we look at this graph of cosine, this will be started from here. And same, if we take the horizontal line, there will be some area that is still, there will be not one-to-one functions, right? But if we cut the, this is 0, this is pi, right? If we just cut from 0 here to pi, there will be perfectly one-to-one functions, right? Or we have an inverse here. So we need to cut at 0 to pi, okay? So this will be resulting, so 0 from here, 0 to pi. So from the first and second quadrant, we will have the domain. The domain will be from 0 to pi. And the tangent also similar. And the tangent will also similar with the sine. If we draw the tangent, maybe pi over 2 here. So it will be going infinitely on negative pi over 2 and pi over 2. So we will have the domain will be negative pi over 2. The difference with the sign is the equal sign. In sine, you will have less equal or great equal, but in tangent, we will not include this pi over 2 and negative pi over 2. Okay. So the domain here will become the range on inverse. Okay. This is domain on the trigonometric, but if with the inverse, this will be the range, right? Okay. So let me write here. So sine inverse, this will be having domain. Sine is from we can have from -1 to 1, right? The maximum value, and the range will be depends on negative pi over 2 to pi over 2. And cos inverse, similar, but different in range. This will be from 0 to pi. And tangent, domain, because it can have infinite value, we can have all real numbers. And the domain, this will be from negative pi over 2, but not include negative pi over 2 to pi over 2. Not include pi over 2. Okay, if we write sine inverse x equal y, we can write sine y is x. Okay, same thing with the cos inverse, and same thing with the tangent. And how to use it, I believe you are already familiar with. Okay, so if we have, for example, cos and then sine inverse 3 over 5. First, this is, I think, it's quite simple. We can draw the rectangle, like I always telling you in other classes as well. Write the number theta, okay? And if sine inverse 3 over 5 is theta, then you can write that sine theta is 3 over 5. Okay, sine theta is 3 over 5, and we got that this is 4. Okay, so theta is sine theta is 3 over 5. So cos of sine inverse 3 over 5 is basically saying cos of theta, okay, is 4 over 5. Okay. Okay, and sometimes we are not using any numbers at all, but we are using the expression of x to express the inverse in algebra. Okay, and we can also doing that, and I think mostly we are doing it in calculus 1, right? So we call this is the composing trigonometric function and its inverse. So if we have tangent cos inverse x, okay, first just draw a triangle. Unless you are familiar and already know how to use it, you can do it directly. But if not, then draw the right triangle. Right, let theta is cos inverse x. Okay, and write down all the things here. So cos x is cos theta is x. Okay, so when cos theta is x, this will be x. This will be 1, right? Okay. And the other one, the other side, the opposite side will be square root of 1 minus x squared. Okay. Okay. Now, the question is asked the tangent of the cos inverse x, so which means tangent theta. So from the triangle we got, the tangent will be square root of 1 minus x squared over x. Okay. And sometimes if you remember the calculus part, sometimes you are asking the derivative, right? So the derivative here, if you remember, this is if I write in secant squared theta here, then we need to find the secant theta from the triangle. So secant theta is 1 over cos or 1 over x. Or we can have, this is 1 over x squared. This is just to remember the calculus part. If the question is asking the first derivative. Okay, I have still around 20 minutes. We'll finish this part with the, I think this is the last one. Yeah, two sections. I think I will finish in 20 to 30 minutes. Okay. Okay, first, let's look at this triangle here. This triangle is having A, B, and C. And let's say we have an H there to see that this is having the right triangle inside. Okay, let A be C. This A is the angle. Okay, let A be the angle. And in front of the angle A, we will have the sides here we called A. And in front the capital B, the angle B, we have sides B. And same way here. Okay, let me make two different C. Okay, the C, the big one here. Okay, remember that in the area of triangle, we need to find H in terms of the sign, right? So this H is, if you remember well, this is B sine this C, right? So sine C. Okay, got it? If you write down the area of triangle, we will get A B sine C half. Okay. Right? And in the same way, okay, if you check the other line as well, for example, this line here, let's say this is another H, okay, another H. This is also another H from the C. Okay. And this will be another H. Okay. If you look, the area, the whole area will be, this will be equal with half B C sine A, and this is equal with, let me move, it's half A B, sorry, A C sine B. Okay, we solve this, okay, and we solve each other. Sine C divide by C, okay, divide by B, and divide by A. This is divide by A, divide by B, divide by C, and we will have this. Okay, this will be the it's called the law of sine. Okay, so this is multiply with the whole thing multiply with 2 over ABC. Okay, so if you have triangle, and at least you know, at least you know two sides, one angle, or two angles, one side, you can find the other one with this law of sine. Okay. So the idea is sine of the angle here over uh, the opposite side of that angle equal with other sine with their opposite sides as well. That's the law of sine. All right. So this is law of sine. Okay, let me going through the other case as well. Okay, let me take with the help of the y-axis as a Cartesian, and we have the triangle here. Okay. Okay, let's say we have this is C, the angle C. This is the A. This is the B. And in front of C, there was side C. In front of angle A, there will be A. In front of B, there will be B. Okay. And let's take this as, you see that this is the height of, you have the right triangle here. Okay, consider the triangle ABC. Okay. Okay, let's say we have an angle here, angle A. Okay. And let me write in dark blue. Okay, and in A, this is perfectly at the origin, 0, 0. At B is 0, C0, right? The coordinate. At C here, what is this? If you look at this triangle on the left, this triangle here, so we have this is, let's say, y and x. Okay. And we have this also an angle. This will result in b cos A, right? And b sine A. Okay. X over b and y over b, cos and sine. So we have in the coordinate c b cos A and b sine A, right? Okay, good. Okay. Okay, now we have a big triangle. Okay, so let's say we have the point P here. Okay, so we have BCP. Okay, BCP. Okay. We have BCP. Okay, consider the triangle BCP. Okay, if BCP is a right triangle, then the sides A here is the hypotenuse, right? Okay, this will be the hypotenuse. Then we can use Pythagorean theorem. A squared equal B sine A squared, right? Plus X plus C, right? Or the X is B cos A plus C squared, right? Okay, yeah. So this Y squared plus X plus C squared equal to A squared, okay? So let me write that in terms of B cos A and B sine A. So B cos A B cos A oh, sorry, sorry. Um, we can consider, I forgot to mention. Let me write this in terms of, let me write this in more clear uh, distance. Okay. Let me write as a distance. I think it's better because it's more uh, clear. So distance uh, CP, CB, okay. So distance CP, let me write the distance first. Distance CP is B sine A minus 0. Sorry, not CP. I think we can just use CA directly. And CB a squared and a PB B cos A minus C squared. B sine A B cos A minus C. Okay. Then A squared will be B cos A minus C squared plus B sine A squared. Okay, I think this will be better. Actually, the first one is also okay, but you need to have the B cos A in terms of negative, right? Okay, if you want to have that. But let's just write here. A squared is B squared cos squared A minus 2BC cos A plus C squared minus B squared sine squared A. Oh, plus, sorry. And B squared is cos squared A plus sine squared A, and then minus 2BC cos A plus C squared. Or we can write B squared plus C squared minus 2BC cos A. And this terms is, we call the law of cosine. We can do to the other side as well. B squared is A squared plus C squared minus 2AC cos B. And C squared is A squared plus B squared minus 2AB cosine C. Okay, the whole thing here is the law of cosine. So whenever you have a random triangle and you know some sides and angle, you can either use the law of sine or law of cosine to find the other angle or other sides as well. Okay, so law of sine and law of cosine. I think one more section. just additional notes for the Heron's formula. So to find the area, we can also use the Heron's formula, which is the square root of s minus a, s minus b, s minus c, where s is the perimeter of a plus b plus c. This is we call semi-perimeter of triangle. That is half of perimeter. And how we are going to prove that? Remember that area that we have is from the half a b sine c. Okay. If we try to look at this side, so this is h, this is the c. You know that the h is the a sine c. Okay. A sine c multiplied by b divided by 2 is the area. Okay. If we try to square this, we have this terms. Okay. And we can write sine squared as in this 1 minus cos squared. And we can also write this, factorize this 1 minus cos squared. Okay. And from the law of cosine, we have the c squared is a squared plus b squared minus 2ab cos c. We can write this in terms of so we plus this with plus 1. So this will be 2ab plus a squared plus b squared minus c squared. Or we can write a plus b squared minus c squared divided by 2ab. And we can write this in terms of a plus b plus c, a plus b minus c. Okay, this is also another term of a squared minus b squared, right? Okay. We can factorize this. And similarly, we will have 1 minus cos c with the same method. We will get a c plus a minus b, c minus a plus b. We substitute this expression 1 plus cos c 1 plus minus c to here. Okay. We substitute and we will get this a squared and b squared will cancel with this one. And this 4 I will distribute to all of the a plus b plus c divided by 2, a plus b minus c divided by 2, c plus a plus minus b divided by 2. This is 2, 2. And c minus a plus b divided by 2. And we know that this from the definition of the S, we get that this is perfectly, we get this is S minus C, and S minus B, and S minus A. This is A squared. So the A, thus the A is the square root of S minus C, S minus B, S minus A. Okay, that's the Heron's formula, and I think that will do for chapter 6. So chapter 6, I'll finish. Okay. The continuation of this will be on the analytic trigonometry. I think we have one student who will be presenting that analytics. Yeah, I think so far we already have most of our sections covered. So yeah, I think that will do for our lecture today. So prepare your presentation tomorrow. We will have an online presentation. Before we present, I will randomly select using this website generator for picking who will be presenting. And I think that's it for today. And oh, by the way, the so hopefully we can finish all the presentation by the end of the December. Okay, so uh, if we start tomorrow, maybe one or two students, maybe one student. Okay, but it depends on how much we have discussions. But I expected for Wednesday class we'll have at least one because we have only 1 hour. If we have a Tuesday class in next week, we have maybe two students, so 1 hour discussions, and then other students and 1 hour discussion. So we'll finish by, I think we need to have at least eight students. So yeah, I think in 3 weeks we will have all finished. And then what will we do next will be the report. Okay. Yeah, Blessing. Yeah, Blessing. What is your question? And Blessing, you didn't write any report. You didn't do the assignment, the quiz. So I don't know what to ask. Do you know that? Have you checked your Google Classroom? Yeah. And where is your video? Did I mention about the where to submit the video? I think I've mentioned in the Google Classroom. Please read the Google Classroom. If you don't know how to do it, please ask your friends. Okay. You miss out on most of the quizzes, assignments, and the video. Okay, so if you are missing out again in the future, you don't need to take this class, and you can take it next year again. Okay. Okay, and if you know the blessing, please tell him. Okay, please tell him. He missed out the quizzes, assignments, the video he didn't submit. Okay. Also, what the topic he is on, he is not mentioning. I message him, I email him, I write down in the Google Classroom, and he didn't reply me at all. Okay. So please mention this to him. If he mess up, doesn't need to take this course this semester. Take it again next year. Please tell him that. Okay. Okay. I think we'll finish and see you tomorrow. We'll have the online presentations. So